Last time on Monday, we did 4.1, where we learned to graph a basic sine and cosine function. Let's review that a little bit. Suppose I have y equals to 2 plus 3 sine x. Then if I want to put them in these 2 by 4 columns, 2 by 4 table, I will do this a lot today. Then the graph will be starting from where? From the top, middle, or bottom?
Middle?
The center.
Yeah, it will, because it's a sine graph, right? So it will be start from the center, from the middle, go up here, and then go down here, go up again. So approximately this is the graph. Now then what happened to the center?
It's 2.
Okay, what's the amplitude?
Three.
The amplitude is 3, so the center is 2. The amplitude is 3. So what is the maximum then?
Five.
That will be 5. And we get that 5 from 2 plus 3, right? Now from the center, if we go down by the amplitude, what do we get?
-1.
-1. So the minimum is -1. It comes from the center minus the amplitude. Now then, the period is pi. So start from 0 plus 2 pi, I get 2 pi. And the cutoff in the middle is pi. This is pi over 2. This is 3 pi over 2. Now, let's change this to, instead of sine x, instead of sine x, I want to change this to cosine x. So I will take the whole thing here. Okay, and then I copy that. But then I do this variation. Suppose I change this sine x here, becomes cosine x. Then what will change? Will the center change?
No.
How about the amplitude?
No.
No. So the maximum minimum also stay the same. Okay, the difference will be instead of starting from the middle, from the center, for cosine, it starts from the top. That's what the sketch of the graph approximately. Okay, now that's something we didn't learn last time, but I think that's quite easy for us to understand. So if we have sine graph, we start from the middle, goes up and down, okay? And then if we have cosine graph, we start from the top, we go down and up. Now, now what happens if I apply negative in front of that? Before we do so, let's take a look on my graphing paper. Okay. if we take a look, y equals to sine x, this is what it looks like. Now then, suppose I put negative in front of that sine x, y equals to negative sine x. What will happen is the graph is being flipped upside down. So the part above that, the sine graph, the purple one, you reflect that. So the one above becomes the one below. You reflect it. The further it goes up, when you reflect it, it becomes go down. Okay, so instead of going this way, you reflect that becomes going this way. You see what I mean?
Yes.
Okay, so if we go back to our node, then hold on. Suppose I look at this and I change the plus here. Let me make it minus. Then what happened is, instead of following the red color, you need to flip that upside down. You see what I mean? That's what the graph looks like. So they still keep the same center, the same amplitude. The amplitude doesn't change if you put plus or minus in front of the coefficient. Okay, it's the shape of the graph being reflected with respect to the center. Are you with me?
Yes.
Okay, now with that mindset then, let me ask you to try graphing this, get the sketch. For example, let's say y equals to 3 minus 2 cosine x. Okay, try get that, get the information, the center, the amplitude, the maximum, and the minimum first. So find the center, the amplitude, which basically gives you the, from there you will get the maximum, you get the minimum. Once you get those, then you do the 2 by 4 table. Okay, what's the center?
Three.
Center is 3. How about the amplitude?
2.
2. So what's the maximum?
Five.
Maximum is 5. the minimum is
1.
1. From here we see that the range is 1 to 5. Now, because the range is 1 to 5, not including 0, right? It means the lowest this graph can go is y equals to 1. Therefore, we can answer one side question, what's the x-intercept? Because this range does not include 0. Then no x-intercept. Okay. Well, anyway, let's go back. The center is 3, the maximum is 5, the minimum is 1. We start from 0. The period is still 2 pi. And this is negative cosine. So should I start from the top, the middle, or the bottom?
Bottom.
From the bottom. That's right. So from the bottom, I go here, and then I go here. Okay, approximately that's what it looks like. That's what this y equals to 3 minus 2 cosine x is there. I will go a bit further. The new stuff. What happened if, so far we have the following situation. So far we have y equals to some number, let me call that c, plus some coefficient for sine or cosine of x. Sine or cosine of x. That's what we have so far. Now this c here is the center. This a here, to be more precise, the absolute of a, because a may be negative, right? Now the absolute of a will be the amplitude. That's what we have so far. Now, in the next stage, I will play further. What happens if we have c plus a sine or cosine bx? So I put coefficient on the angle x. So for example, we want to observe what's the graph look like for, let's say the simple one first, y equals to sine 2x, okay, as opposed to sine x only. Let's take a look on our graphing software. I changed this sine x, compare this sine x with sine 2x. Oh, that's quite confusing to see, huh? What the heck is that, Thomas? Okay. Let's copy this and put it on our note back so that we can observe that better. Now, we will take a look from this point from here. Oh, I'm sorry. This is, give me a second. Give me a second. Oh, this is better. Okay. Now, I want you to see from this cosine part here. This is still not enough. My bad. Still not enough. I think this is better now. Okay. Notice the purple color. The purple color, the purple one. This is the graph for sine. This is the graph for sine. It finished the cycle in 2 pi. One cycle. Do you see that? The purple one only. Okay. Now, once I multiply by the angle by 2, so this is y equals to sine x. Notice that the period is 2 pi. That's what we know. Now, the graph for y equals to sine 2x finish actually 2 cycles there. From 0 to 2 pi, it finished 2 cycles. This is the first cycle. And this is the second cycle. So can you tell me what is the period for y equals to sine 2x? Well, in 2 pi, it makes 2 cycles. So in 1 cycle, it will take pi. It just takes pi to finish 1 cycle. Let's take a look here. This is 3.14 something. Do you see that now?
Yes.
Okay, so when I change the angle, x becomes 2x, then the period is divided by 2. Basically because we play the movie twice faster. So it finished the cycle, the period, in half time. Okay, so if I try to summarize this picture above into my 2 by 4 column, then you will see the center is you see that the center stay the same, right? The center stay the same at 0. Compared with the sine x, the center is still at 0. The amplitude is still 1. The graph still sine graph, the regular sine graph. The center is 0, the maximum is 1, the minimum is -1. It starts from 0, but instead of ending at 2 pi, now it becomes ending at pi. You see what I mean?
Yes.
So the pi becomes pi over 2, and this becomes pi over 4. This becomes 3 pi over 4. You can see that from 0 to here, that's the period. This is the period. Now then, the period is divided by 4. That gives you the some textbook call that quadrantal period. So you add pi over 4, another pi over 4, another pi over 4, another pi over 4. The period is 2 pi over 2, which is pi. So the quadrantal period is pi over 4. Because one period, we have 4 quadrants, right? So you divide that further by 4. Is it okay? Now, in general, the period, in general, the period is equal to 2 pi over coefficient of the angle. In this case, the coefficient of the angle is 2. In this case, the coefficient of the angle is 2. So the period then, originally the period is 2 pi, divided by that 2, I get 1 pi. Okay, let's do more problem. Let's make it a bit harder. Suppose I have, for example, y equals to -3 cosine 4x. What will the graph look like? Now, I want you to do that routine first. Find the center, the amplitude, the maximum, the minimum, but this time we add more. What's the period? Okay, now after that, then try to graph it.
Is cosine positive or negative?
Repeat
Cosine,
again?
are you adding cosine or are you subtracting cosine?
Nothing. Nothing in front of that. It's just -3 right away. -3 cosine 4x. So actually, implicitly, I have invisible 0 here. So what's the center?
Zero.
The center is 0. How about the amplitude?
-3.
Almost right.
3.
Amplitude always positive. Yeah. So if you see -3, use the positive one. How about the maximum?
3.
3. Yeah. So and minimum is
-3.
3. The period will be 2 pi over
4.
which will give us pi over 2, right? Okay.
Yeah.
So from that 0, this is 3, this is -3. We start from 0, we end at pi over 2. So what is the midpoint here? Between 0 to pi over 2, what is in the middle?
Pi over 6.
No, pi over 4. Divided by, when you get the midpoint between 0, so let me do a little scratch word. 0 plus pi over 2 divided by 2. That's pi over 2 divided by 2, the same to pi over 2 times 1/2. You see that?
Yeah.
Okay. Now that's how I get the midpoint between the 0 and pi over 2. Now this guy here is the midpoint between 0 and pi over 4. Can you try to find what's that?
Pi over 8.
Pi over 8, that's right. Now how about this guy? That's the midpoint between pi over 4 and pi over 2.
Two pi over 8.
2 pi over 8? No, I don't think so. I don't think so. Let me do the scratch word here. So pi over 4 plus pi over 2 all over 2. Now then I will multiply the top and the bottom by the LCD, because you see that's a complex fractions, right? One way to do it is multiply the top and the bottom by the LCD. I get pi plus 2 pi over 8. That's 3 pi over 8. Now, if you don't get used to do it that way, then you may need to do it a bit longer. If you do it a bit longer, then you will combine this first. Is that okay? You will get pi over 4 plus 2 pi over 4. We need to do the LCD, you see right? That will give me 3 pi over 4 all over divided by 2 or multiplied by 1/2. That gives me 3 pi over 8. The same answer we get earlier. So this is 3 pi over 8. Now then, go back to now I have the frame already. Then we ask ourselves back. That's negative cosine, right? Do I start from the top, middle, or bottom?
Bottom?
Start from bottom, because cosine being flipped upside down, instead of from the top, we will start from the bottom. Approximately like that. Is it okay? Now, your turn. You try this time. Do you still need to see that? Let me bring it up. Okay, this time you try, for example, 1y equals to 1 plus 1/2 sine 3x. Oh, this one is so hard. Okay, get the center, amplitude, maximum, minimum, and the period. And then you go to the rectangle, the table, right? The 2x4 table. I think you will have hard time. You need to spend more time on the x-axis. The period, I believe, is 2 pi over 3, and then from there you need to play more. Okay, let me give you around 5 minutes to work on that. Okay, let's see. What's the center?
1.
1.
And the amplitude is?
1/2.
1/2, that's right. So the maximum will be
3/2.
3/2. Or if you feel comfortable with decimal, in other words, it gives you a nice decimal, just use decimal. Okay, you can use 3/2, which is 1.5. And how about the minimum?
1/2.
1/2, which is 1/2. How about the period?
2 pi over 3.
Pi over 3. How about the quadrantal period? That's 2 pi over 3 divided by 4. That will give you pi over 6. Now, how we will use this later? Let's take a look. Okay, it seems like I just get locked out earlier. Hello?
You're good.
You're good
Okay.
now.
Yeah, okay. I think my son just passed by and then the signal disappeared. He's very good in changing the signal. Okay, now this is my... Depends on the difficulty level. I usually give 3 or 4 points for this graph here. Now, then how do I give you points? 1 point for the shape of the graph. So this is the graph of sine, start from the middle going up. This is the 1 point. Okay, now the half point is on the y. I start from the middle is 1, the maximum is 1.5, the minimum is 0.5. And 1.5 points on the axis. So I start from 0, the period is 2 pi over 3, and what will this be?
Pi over 3.
Pi over 3, and how about this one?
Pi over 6.
Pi over 6, and how about this?
Pi over 2.
Pi over 2. Okay, now besides doing it this way, you can start the following. You start from 0 and you add the quadrantal. You get pi over 6. 0 plus pi over 6 is pi over 6. You add another quadrantal. So basically we do pi over 6. That's where you get it from. Plus the quadrantal period, pi over 6. That's 2 pi over 6, which is pi over 3. Okay, now then from here to here, you add another pi over 6. You add another pi over 6. You will get 3 pi over 6. Which is pi over 2. Now, you can check if you add another pi over 6, you will get 2 pi over 6. I mean 2 pi over 3. Okay, so besides using the technique I showed you earlier in which you get the midpoint, so you get the midpoint between 0 and 2 pi over 3, you get pi over 3, and then the midpoint between 0 to pi over 3, you get this, the midpoint between this guy and that guy, you get this way. Another way is actually you add the quadrantal period. Okay, you add the quadrantal period like that. That's just another way to look at that. Now, let's do maybe one more problem. I think we are fine here. Let me give you the suggested homework right away. Oh yeah, you know what? Let me ask you to do one more problem. This time I take the question from the book. That was a question from the book too. Number 34. Number 34. Y equals to -2 plus 2 sine 4x. Let me ask you to do this together with your break. I ask you to do this problem, let's say in 5 minutes, together with your break, maybe 10 minutes, together with your break, 10 minutes. We come back at 8:20. Either you do this first and then take your break, or you take your break first and then do this, either way. Let's see, the center is -2, the amplitude is 2, so the maximum is
0.
0, the minimum is
-4.
minimum is -4. How about the period?
Pi over 2.
Pi over 2. But in your test, you need to write 2 pi over 4 first before you simplify it. Is it okay? And how about the quadrantal period?
Pi over 8.
Pi over 8. Now then from there, you go the 2 by 4. I start from the top, middle, bottom.
Middle.
From the middle, do I go up or down?
Up.
Go up. Straight, sorry. Okay, approximate like that, and then this is 0, this is pi over 2, pi over 4, pi over 8. I think this is 3 pi over 8, huh?
Yeah.
Okay, now let's go on to 4.3. 4.3 is continuation from 4.2. And right now we involve what we call a phase shift. It has something to do with the following situation. Let's look into our graphing paper. Suppose I go back to a more basic function to deal with. Let's say we talk about the absolute of x. No. absolute of x. Now that's what it looks like. Now then what happens if I keep that absolute value pattern and I change that x becomes x minus 2. So I replace that x becomes x minus 2. Now see what happened. See what happened? The purple graph is the graph of absolute of x. When I replace the x by x minus 2, we shift to the right 2 units. So you see that when I have y equals to absolute of x now becomes y equals to absolute of x minus 2. Okay, the change from x, I replace that by x minus 2, makes the graph moves 2 units to the right. But the whole graph still stays the same. Are you with me?
Yes.
Okay, now then, that gives us the idea that later on, if I have, for example, y equals to sine x minus pi over 3, then the shape will be the same to the shape of that y equals to sine x minus pi over 3 is the same to the graph of y equals to sine x. The difference is you move that to the left or right?
To the right.
To the right, how many units?
Pi over 3.
Pi over 3. Now you will see that nothing else changed from the sine x. The center will stay the same, the amplitude will stay the same, the period will stay the same, but the starting points, instead of starting from 0, now we start from pi over 3. The x will start from pi over 3. Now let's take a look. So the center is still 0, the amplitude is 1, so the maximum minimum is -1 and 1. And then the graph still the graph of sine x. It's still the graph of regular sine x. Now, however, instead of we start at 0, now we start at pi over 3. We start at pi over 3. Is okay? Now, the period is still 2 pi. The period is still 2 pi. So after one period, this will be pi over 3 plus 2 pi. Because remember, we shift that to the right by pi over 3. So all the x's will move by pi over 3. Okay? Now, if you do some algebra, this is equals to 7 pi over 3. Now, then we use the same method that we did earlier. Either you use quadrantal or the midpoint. This will be 4 pi over 3. This is 5 pi over 6. This is 11 pi over 6. Okay, but the shape is still the same. The maximum, the minimum that we learned before, the center is still the same, the period is still the same. Is it okay? Now let me ask you to try what will we have if, I think you still want to see that, sorry. I would like you to try, for example, y equals to negative cosine of x plus pi over 6. Okay, try to sketch the graph. Especially the blue part here, the x value, especially the x value that you have down here. I need you to give me the next, the correct ones. Okay, I'll try that. Let me give you 3 minutes maybe. Okay, let's see. The center is 0. The amplitude is 1. The maximum therefore is 1. The minimum is 1. Its minimum is -1. The period is still 2 pi, right? Because the coefficient of x is 1, it's 2 pi over 1. And the phase shift, so instead of starting from x equals to 0, the phase shift will be
Negative pi over 6.
negative pi over 6. That's right. Now, the notation for phase shift is phi. It looks like this. You can say it looks like a p, lowercase p, but it has some tail. Okay, now that's the phase shift. So we will start from negative pi over 6. The period is 2 pi. The center is 0, maximum is 1, minimum is -1. I start from negative pi over 6. When I add 2 pi, it will be
11 pi over 6.
11 pi over 6. That's right. I almost say 5 pi over 6, but no. It's 11 pi over 6. That's right. So what will this be? This is 5 pi over 6 here. 4 times pi over 3 here, I think. And this is 2 pi over 3. Oh, I think I got it wrong. 16 times 8. 4/3. It's 4 pi over 3. Do I start from the top, the middle, or the bottom?
Bottom.
Bottom.
From the bottom, because negative cosine, right? Like this. I equals to 4 minus 3 cosine of x plus, let's say, pi over 4. How many minutes you think you need for this?
5.
Okay, 5 minutes. The center is 4. The amplitude is 3. The phase shift later on you will see is negative pi over 4. Okay, give you 5 minutes. The center is 4, so what's the maximum?
7.
Maximum is 7. How about the minimum?
-1. I mean, sorry, 1.
1. And the phase shift is negative pi over 4, while the period is 2 pi. So this guy here, negative pi over 4 plus 2 pi is what?
This 7 pi over 4.
That's 7 pi over 4. That's right. And then this will be 3 pi over 4. And this is pi over 4. And this is 5 pi over 4. Then as for the graph, that will start from the top, middle, bottom.
Bottom.
From the bottom. So you see the shape will be only either sine or cosine. It's either the regular shape or upside down, right?
Yes.
And then the center, maximum, minimum, here, here, here. This is the phase shift. This number here should be the same to this. And this number here has to be this number there has to be the phase shift plus the period. Is it okay?
Yes.
Now, let's make it even harder. What happens if I have a more general situation? Suppose I have y equals to, let me see, y equals to, this question from number 30. Y equals to 3 plus 3 times cosine of 1/2 x plus pi over 3. Now, the problem is this 1/2 here is still inside the parentheses. I need to factor that 1/2 out. Okay, 3 plus 3 cosine 1/2 of x plus 2 pi over 3. You see what I mean? We need to rewrite it first. Then from here, we will see that the center is
Three.
How about the amplitude?
3.
So the maximum is
6.
the minimum is
0.
how about the period? 2 pi over the coefficient of x,
1/2.
which will give us 2 pi times the reciprocal of 1/2 is 2. 4 pi. While the phase shift is negative 2 pi over 3. Okay. So we if we have coefficient in front of that x, and they are all inside the parentheses, then you need to factor that out first. Let me emphasize that here. This guy here has to become like this first. You see what I mean? Now then, once we get this information center, amplitude, maximum, minimum, period, and phase shift, then we can go on with the 2x4. Okay, let's do the shape first. So I start from the top, middle, bottom.
Top.
From the top, because it's cosine with positive coefficient. Something like this. And then I have 4 pi, negative 2 pi over 3 plus 4 pi. Oh, what would that be?
10 pi over 3.
It's 10 pi over 3.
Then it's 4 pi over 3.
4 pi over 3 in the middle. It's pi over 3 here. Here. This is 7 pi over 3. Okay. Now let me ask you to do a problem from my old test. This is a problem from my old test. Give me a second. Okay, try this question. This question is from summer 15, math 241, test 2, number 5. Let me give you 5 minutes. Okay, the first thing we need to do is to factor the 3 out. So this is 3 minus 4 cosine 3 parentheses x plus
Pi over 6.
pi over 6, 3 times something equals to pi over 2. So that something must be pi over 2 divided by 3. Okay, that's how we get that pi over 6. So the center is
3.
amplitude,
4.
the range. What is the maximum?
7.
The minimum?
Ooh, -1.
Okay, so when I say before maximum, minimum, that's actually to help us to see what's the range. How about the period?
2 pi over 3.
2 pi over 3. And the phase shift is?
-pi over 6.
Negative pi over 6. That's what we need to graph. 3 here, 7 here, -1 here, negative pi over 6. And 4. So this is pi over 2. Is it right? This is pi over 6. This is 0. This is pi over 3. And this is the graph of negative cosine. So do I start from the top, middle, or bottom?
Bottom.
Start from the bottom. Like that. Okay. So we are basically done with what I need to do with these 4.2 and 4.3. Now, with the time I have left right now, I will go over the type of graph that I didn't go over before. The graph for tangent. The graph for tangent, let's say that's the x-axis and this is the y-axis. The graph of tangent will look like approximately like this. Approximately like that. And it has asymptotes. No, I don't like the color. Change it to or other color. Maybe change it to this one here. It has asymptote. What is asymptote? Means the graph does not actually cross that line, but the graph stops there. Not really stop. It looks like this. Okay, and I will repeat this pattern. I will repeat this pattern, this red pattern here again and again and again. So approximately it looks like this. Sorry with my ugly graph. Like this. And then the asymptotes actually happen at pi over 2 and every pi after that. So 3 pi over 2, negative pi over 2, negative 3 pi over 2. Now, if you want to see a better picture, you can see that from your book. Okay, I can use my graphing paper right now to show you what the graph of tangent x look like. It's like this. Notice that the domain is all real numbers except this pi over 2, 3 pi over 2, and 5 pi over 2. Basically, from pi over 2, every pi after that, every pi after that, every pi after that. Okay, but the range is all real numbers. So this is pi over 2. And pi after that is 3 pi over 2. Negative pi over 2. Negative 3 pi over 2. Negative 5 pi over 2. Okay, so we say that the domain for tangent of tangent x, what kind of value we can use for x is all that x where x is not equal to pi over 2 or any integer multiple of pi. Okay, so all real numbers, you can use any x as long as it is not pi over 2 or any integer multiple of pi from there. Okay. Basically, we need to avoid pi over 2, 3 pi over 2 because at those points, cosine is negative. I'm sorry, cosine x is 0, right? So when cosine x equals to 0, when this is equals to 0, then the tangent is undefined. Can you follow me?
Yes.
Okay, so if we want to know what is the domain of tangent, the domain of tangent is all real numbers except the places where cosine x equals to 0. Now, if we look back, the domain of sine and cosine are all real numbers. Domain of sine x is all real number. In other words, you can plug any x you like, and we still get a value. The domain of cosine x is also all real numbers. Now, let's summarize a bit more, just a bit more, please. How about the range of cosine, of sine x? What is the range of sine x? The maximum is 1, the minimum is -1. That's the range. In fact, the range for cosine x is the same. However, the range of tangent x is the range of tangent axis, you will
Negative
see
infinity?
up to
Infinity?
negative infinity up to positive infinity. Or we can say that's basically all real numbers. Okay, so for whatever y you choose, whatever you pick a number, there must be an angle such that tangent of that angle goes to that value that you choose. There must be an angle such that tangent of that angle equals to 10, for example. If you choose, let's say 150, then there must be an angle such that tangent of that angle is 150. Okay, that's for the range. Now, how about secant, cosecant? I don't think I will ask you to graph tangent, but the question of domain of tangent, the range of tangent is a fair game. Okay, now for secant and cosecant, I will not ask you to graph them either, but I would like to go over that here. Graph of y equals to secant x and y equals to cosecant x. I didn't go over this with in 4.2, 4.3, and 4.4 because I want you to focus on sine and cosine first. You know, if you are good with your sine and cosine, actually graphing secant and cosecant is on the easy side. Okay, now let's see what's the graph of, for example, secant x first. Are you seeing my graphing paper, by the way?
Yes.
Okay, so y equals to secant x. Seems like our secant x has no pattern, huh? Now, I want you to compare that with, now secant x is the reciprocal of
Cosine?
cosine. Now, let's take a look. Thomas, I see that, but I don't really see what's the relationship. Okay, that's fine, don't worry. Let me copy the graph. I need to copy the graph to our notes because I want people who missed the lecture can see the notes so they can see what we see also. But at the same time, I can write on this note. Oops, sorry. Okay, now the graph of sine x was in this box earlier. The graph for sine x was in this box. Actually, cosine x. The graph of cosine x was in this box. No, I don't like it. Now, this is the graph of sine x. Do you see that? If I
Cosine
draw
X.
it in, yeah, if I draw it in one period only. Now, then the graph of secant is basically as the following. When cosine hits the top, cosecant hits the bottom, and it goes to infinity. So it's this is an upside cup here, and when the cosine hits the bottom, the secant actually hits the top. It's like an upside down cup. So you can see this way. You can say the following. Suppose I do it fast. You don't need to write this down. Suppose this is my cosine graph. Suppose this is my cosine graph or sine graph. Yeah, cosine graph first. Let's say this is my cosine graph down here like this. Let's say that's my cosine graph. Then my secant graph will be the following. Okay, so this is y equals to secant, while this one here is y equals to cosine. Now, why do I want to do this? Why do I show you this? Because of the following. I really don't like this. This is better. Okay, because of the following. Suppose I ask you to graph, for example, graph y equals to negative negative 2 cosecant pi x plus pi over 2. Then what is the reciprocal of cosecant?
Sine.
Sine. So what I will do is I will try to graph this first. Y equals to negative 2 sine pi x plus pi over 2. I factor the pi. Okay. Now then I try to graph that. Okay, graph that small enough here. I try to graph that. So let's see. For this guy here, the center is 0, the amplitude is 2. So the maximum is positive 2, the minimum is negative 2. The period is what's the period?
2.
2. It's 2 pi over pi, that's equals to 2. And the phase shift is negative 1/2, right? So I start from negative 1/2 here, plus 2, that will give me 3/2. So this is 0, this is 1/2, this is 1. And the graph for sine will be something looks like this. I'm sorry, it's negative sine. It's negative sine. So it looks like this. Correct? Okay. Now then we will look back to the graph for cosine. The idea is every time you have bump up, it will be a up facing up cup. Every time they hit the center, you have an asymptote. You have asymptote here. Now you have a valley here, the minimum. Then for the cosecant, it will be the maximum. Like that. Okay. Now from here, we can also see what is the range of this cosecant. Now, what is the range for the sine version? What is the range for the sine version?
Why you been like that? Negative 2 and 2.
Negative 2 up to 2. Okay. Now, then the range of the cosecant version will be everything outside of that range, the earlier range. That will be from negative infinity up to negative 2. negative infinity up to -2. And in fact, we know that it hits -2 here. You see that? Here. Union from 2 to infinity. So it's kind of, it's blank between -2 to 2. You see? It has 2 though. Okay, it reached +2 here. So only the endpoints -2 and 2 actually coincide. Okay, what we have here is what we have there. Is what I mean?
Yes.
Now let's do it super fast. Okay, suppose I ask you, I give find the range of y equals to -3 minus 4 secant 5x plus pi over 3. And the way we do that problem is you take a look first, what is the range? Find the range of y equals to -3 minus 4 cosine of 5x plus pi over 3. What is the center?
-3.
-3. How about the amplitude?
4.
4. So the maximum is 1. The minimum is -7. Therefore, the range is, oops, what did I do? The range is -7 up to 1. Right? Now then, if we go back to our original question, what is the range of that original function? Then the range will be everything but that interval. The range will be -infinity up to
-7.
-7 union 1 to infinity. Okay, now suggested homework. For 4.3, suggested homework for 4.3, number 1 to number 20, just do every other odd. 4.2, number 1 to number 7, 17 to 23, and then 33, 35. Also do every other odd. However, go back to 4.3. I want you to focus on number 33 to number 39. I'm sorry, I think I write it wrong. 23. From 23 to number 31. Number 31. So this one you do odd numbers. Okay. On Monday, I will go over very fast 4.4, but the one that I would like you to read, is 4.6. Okay, please read. And there's a chance that on Sunday or on Saturday, I will post a lecture video to prepare you for the Monday's lesson. Okay. That's for today. See you then on Monday.
Any
Question.
suggested homework for 4.1?
4.1. Hold on. Did I give you homework for 4.1?
No, you just told us to read last time. I believe.
Oh, I see. Because they are too basic. They are too basic.
Okay, thank you, Professor.
You're very welcome.
All right.
Anybody else?
Stay safe.
You too.
All right, thank
Yeah,
you.
I have
Thank
a
you.
question.
Bye.